So this video is about wrapping up our exponents law lessons by talking about negative exponents, which is our pre-AP topic, as well as reviewing some of the exponent rules. Okay, so today's goal is to simplify and evaluate expressions with both positive and negative exponents. Just a moment, and we're just gonna fix something here. Okay, so let's recall some of our exponent rules. So the first one is the product rule. So where you have a to some exponent m times a to some exponent n, the product is rewriting the base a and adding their two exponents m plus n. The quotient law is the division of two powers with the same base. So the result is the same base a with the exponents m minus n. Then we have the power to a power law, where you have one exponent raised to another exponent, and the simplified version of that is a to the power of m times n. So you multiply the exponents. And then if you remember the last section, the last lesson, when you have a combined base a times b, you can take that exponent, that's m outside the bracket, and distribute it inside with both of the bases. So you would have a to the power of m times b to the power of m. Similarly, when you have two bases a over b, you can distribute the exponent both on the top and on the bottom from outside the bracket to within. So a to the power of m divided by b to the power of m. Discovering more laws of exponents. So in the second column, use exponent laws to write the expression as a single power. In the third column, expand and simplify each expression. Suggest a rule to satisfy the relationship. So here's the expression. This is a zero exponent, because if you took the quotient law and you wrote down the quotient by subtracting the exponents, so you'd write this as a single power, 7, and subtract the exponents, 6 minus 6. What would that result? Well, that would result in an exponent of 0. So what does that look like when I expand? So, you write 6 sevens on the top. 4, 5, 6, all are being multiplied. On the bottom, I am also writing 6 sevens, all being multiplied. And you notice that each of these cancel. 1 from the top cancels with 1 from the bottom. And if they all cancel out, I'm just left with 1 over 1, which is just 1. So this is equal to 1. So it turns out that any quotient rule being applied to powers, so they're the same, will result in an answer of 1. Okay? Even if the base is a variable, here I would have x to the power of 3 minus 3. So here is equal to x to the power of 3 minus 3, which is just x to the power of 0. So same idea, if I have x times x times x in the top divided by x times x times x in the bottom, all of these cancel each other out. They're all being multiplied, so they all cancel the top and the bottom, and I'm left with 1 over 1, which is just 1. So it turns out that any value except 0 raised to an exponent of 0 is equal to 1. So any base raised to an exponent of 0 will always equal 1. Now, the negative exponent rule. So this is something grade 10 students will learn in grade 10, but as a part of our AP curriculum, I'm going to teach it to you now. So negative exponents. So some of our practice problems, you'd notice that you'd get negative exponents as your answer. So if I did 7 squared divided by 7 to the power of 5, I'd write this as 7 to the power of 2 minus 5. So when you're dividing two powers, you subtract the first exponent minus the second exponent, even if you know the answer is going to be a negative. And that's fine. So I can write this 7 to the power of negative 3. Now, up till now, I would have accepted that as a correct answer, but in mathematics, we often like to express this negative exponent as a positive one. Okay, so how do we do that? Well, we can see how we can do that by expanding this. So if I did 7 times 7 on the top, divided by, so 7 times 7 is 7 squared. If I divide that by 7 to the power of 5, so that's going to be 5 sevens in the bottom. You'll notice I can still cancel some of these out. So if I cancel this one with this one with this, you'll notice that I'm left with 3 sevens in the bottom. So I can write that as a power by saying 1 over 7 to the power of 3. Where does the 1 come from? Remember when you cancel out these sevens, 7 over 7 is equal to 1. So you're leaving these 1s on the top, and 1 times 1 is still 1. So I have 1 over 7 to the power of 3. So how do I go from 7 to the power of negative 3 to 1 over 7 to the power of 3? Well, it turns out that any base raised to a negative exponent is equal to what we call the reciprocal of the base raised to the same exponent. So any exponent, a to the power of negative m, I can write the base a as a fraction, a over 1. So it's a over 1 is still the same thing as a. My exponent is negative m. And if I want the positive exponent, all you have to do is take the reciprocal of the base. The reciprocal of the base means to flip the top and the bottom. That's why I turned it into a fraction. So if I flip the top and the bottom, I'd write 1 over a to the power of positive m. So you change the exponent from a negative to a positive. So same idea here. If I wrote 7 to the power of negative 3 as a base, as a fraction, so 7 over 1. And then when I make it a fraction, put some brackets around it, to the power of negative 3. So this is no different than saying 7 to the power of negative 3. Just 7 over 1 is the same thing as 7. But what this allows me to do is to take the reciprocal, so I can flip the top and the bottom. So this can become 1 over 7. That's my reciprocal. And I can change the exponent to a positive 3. Okay. Look at the next one. So even if you have something like this with two different bases, this can be expressed as they have the same exponent. Why don't I just write this as a single base, 2 over 3, put it in brackets, and write the exponent negative 4 outside? Because remember, it's the same thing as if I was saying distribute the exponent to each one. You have 2 to the negative 4 and 3 to the negative 4. So I'm just going backwards and writing the two exponents in each top and bottom, to writing just one exponent outside the bracket. Okay. And following my rule, I can just flip the base, write it as 3 over 2, that's the reciprocal, and change the exponent to a positive. So here, any fractional base raised to a negative exponent is equal to the reciprocal of the base raised to the same positive exponent. So this expressed in general form, I would take the reciprocal of the base. So a over b becomes b over a, like so. And I change the exponent from a negative m to a positive m. So let's just apply some of these rules, evaluating each. So here, 12 to the power of 0. Any base raised to exponent 0 is 1. Here's a base, here's even a negative fractional base. As long as the exponent outside the bracket is 0, your answer is going to be 1. X to the power of 0, so even if you have a variable, you're going to get 1. Negative 7 to the power of 0. Now be careful, the negative is outside. The exponent only acts on the operator. It operates only on the base. So I have to do the negative first and treat it as if it was 7 to the power of 0. Sorry, not negative first. I just do the exponents first, acting on the 7. So 7 to the power of 0 is 1. And then I put the negative afterwards, multiplied by that negative. Okay? This is different than if I put negative 7 as a bracket raised to the power of 0 outside. This would say the whole thing was positive 1, because now negative 7 is part of your base. But negative is not part of my base here in this question. It's only 7 to the power of 0, and then you put the negative afterwards. Now, if you're adding two different powers, so 6 squared to the power of 0, that's still going to equal 1. Okay? Plus, separated by a plus, you have to put the plus. 6 to the power of 0 is 1, and that's in brackets, squared, so don't forget to square it. 1 squared is still 1, so I have 1 plus 1, which is just 2. Okay, negative exponents. So simplify each expression as a single power with a positive exponent. Then evaluate, where possible. Leave answers as fractions. So I'm going to just answer these questions using my negative exponent rule. So write this as a fraction, 3 over 1, raised to the power of negative 4. The moment you write it as a fraction, put some brackets around it. Then I can flip the fraction by saying I'm taking the reciprocal, so 1 over 3. And then once I do that, I can express the exponent as a positive exponent, positive 4. Next one, negative 4 can be written as a fraction, so negative 4 over 1, put some brackets around it again, raise it to the power of negative 3. Take the, to convert this, again, the idea here is proper form, proper mathematical form. I don't want to express my powers with negative exponents. You must express them as positive exponents. So you flip the base 1 over 4. Keep the negative sign. You don't want to change the sign of the base, but I can change the sign of the exponent. So negative 3 becomes positive 3. Same idea for the next one, right? Negative x is a fraction, negative x over 1. Everything's to the power of negative 6. Take the reciprocal, so it's negative 1 over x. Change the exponent to a positive. Next one, 2 cubed. Well, 2 cubed is 8, so 8 to the power of negative 2. I can write that as a fraction, 8 over 1 to the power of negative 2. Then I flip the base 1 over 8 to the power of positive 2. Okay, and again, you can also distribute the exponent to the top and the bottom once more to say 1 over 64. 8 squared is 64. Last one, it's already in a fractional form, so I flip the base right away. Negative 9 over 7, and change the exponent from negative to positive. And again, I can distribute the exponent to the top and the bottom, so I have negative 9. Don't forget, every fraction has invisible brackets in the top and the bottom, so negative 9 squared over 7 squared, which is just 81 over 49. Example 3, simplify and evaluate where possible. So combine all the rules. First one, product rule and quotient rule. So on the top I have x to the power of 3 plus 2, which is 6, over x to the power of 5. Quotient rule, x to the power of 6 minus 5. Simplify x to the power of 1. Good form says I should just write x. Whenever you have an exponent of 1, just express it as your base x. Now, next one, same idea, product rule again. 3 to the power of 3 minus 2 over 3 to the power of 4. That's equal to 3 to the power of 1 over 3 to the power of 4. Quotient rule, 3 to the power of 1 minus 4, which is 3 to the power of negative 3. And then convert the negative exponent to a positive 1 by taking the reciprocal of the base, 1 over 3 to the power of 3. You can also go one step further by distributing the exponent to say 1 over, will be 1 cubed, which is just 1, and 3 to the power of 3, which is just 27. Okay? So this step here is what you would do if you're asked to evaluate the expression. So this is where I say evaluate. Okay, if it's simplify, then stopping here would be good enough. Next one. So again, flip the base. So here 3x to the power of negative 5 over 2x to the power of negative 5, which would allow me to change the outside exponent to a positive 1. Okay, but once it's positive 1, you really don't need that. So I'm just going to erase everything here. Erase the bracket. Okay, and resolve the exponents that are left over. So 3 over 2, write the x as a single exponent, or single base, and subtract the exponent. So negative 5 minus negative 5, which is just 0. So 3 over 2 times x to the power of 0, and x to the power of 0 is 1. So my final answer is 3 over 2. And finally, last one, write the first term as a positive exponent, so 1 over 2 cubed, or 1 over 2 to the power of positive 3, plus 1 over 2 to the power of positive 3. And if I apply the exponent to the top and the bottom, I have 1 over 2 cubed plus 1 over 2 cubed, which is just 1 over 8, plus 1 over 8, which is equal to 2 over 8, or 1/4.